All right. Welcome back. Hopefully no one was bitten by a zombie this weekend. Everyone got plenty of chocolate. Because you use chocolate to ward off zombies. That's why we have it. So anyway, we have review on right triangle trig. I had told you for a couple of weeks now that you've got to know your special right triangles, SOHCAHTOA. The whole first section is basically that chapter of geometry. Okay. The only difference is giggle. The only difference is maybe in geometry you weren't required to write everything in simplified radical notation. I know that some of our teachers are cool with just decimals, and here you're going to have to rationalize everything. But we've got plenty of experience with that. But before we can go creating what radians are in the unit circle and then start graphing these things, you got to know the basics. So everyone's got their packet or packets, plural, depending on stapler situation. Okay, I'll reload the big one and you can stomp them into single packet later. Every triangle is labeled by sides. The sides are, okay, right triangles. Everything today is right triangles. Later, if it's not a right triangle, don't treat it like a right triangle. And it never fails when we get to non-right triangles where you have to use law of sines and cosines. You're always going to have that kid who tries to do tangent with it, and then they facepalm when they see their test. Okay? On a right triangle, what makes it the right triangle? Always has to have a 90-degree angle. It's going to be marked as such. Things that are always going to have 90-degree angles in context. Height. Remember that height and distance are always perpendicular to a surface. So perpendicular means makes 90-degree angle. I don't measure how tall you are this way. Well, if I measure this way, then Maddie's 6'3". Okay, so height is always going to be perpendicular. Across from 90 is always your hypotenuse. What do you know about hypotenuse? Just like bring back the old geometry knowledge. Always across from right angle, which means it has to be the biggest one. There's something called the triangle proportionality theorem that says biggest side is always across from biggest angle. How do I know in a right triangle that's the biggest angle? Triangle sum theorem, again, for anyone who took an ACT, right? You got to know SOHCAHTOA, parallel lines, triangles add up to 180. Triangle sum theorem says it has to add up to all three angles 180. Well, if this is 90, I can't possibly have something bigger than that because that's more than 180 degrees. So I know that's the big dog, so I know that this is the biggest side. Okay. We are going to name the angles that we're talking about theta. Don't confuse it with empty set. Theta. Theta. Okay. The ta. The ta. No. Do you? It's been 4 days since I put a mark on that board. We can get started. So, we're going to name the angle theta, and the easiest way that I always remember this is that angle and the side immediately across from it that is opposite, because the angle that you're looking at is going to be the gator mouth or the shark mouth or Pac-Man or whatever you want to call it. And that's the stick that you shove in his mouth so he doesn't eat your leg. Okay? It's always across from, opposite from theta. Yes, the difference between opposite and adjacent is opposite is literally across from theta. So you have the biggest one is the hypotenuse, across from 90. You have the one across from theta is going to be your opposite, and adjacent, y'all know the word adjacent means next to. So adjacent is just whatever is next to the other angle formed with the hypotenuse. Okay? So defining those allows us to start getting our trig ratios. You were all introduced to SOHCAHTOA, at least in geometry, if not earlier. Remember, you got to put a little phlegm in there. You have, technically the way it's written is the sine of theta is opposite over hypotenuse. So the cosine of theta is adjacent over hypotenuse. Kind of sound like a Klingon there. And TOA. TOA is the conversational piece of this classroom, having ADHD teacher, tangent. The tangent of theta is opposite over adjacent. I swear there's a D in there. There we go. What you probably haven't heard before was their evil redneck cousins. The reciprocal functions are usually not introduced until after geometry. The reciprocal of sine is called cosecant. Cosecant is CSC of theta, and it's just hypotenuse over opposite. So someone always asks, why isn't the cosine the cosecant? Why isn't that reciprocal? Because then you would effectively be talking about the cosine, and that just sounds weird. But regular old secant, SEC, is the reciprocal of cosine. And the cotangent is adjacent over opposite. Okay? So you have sine, cosine, and tangent, which you already know. But now we've also got cosecant, secant, and tangent. It's literally the same things, but you flip them. Where that might cause a few little cross-eyed moments is you're going to be flipping things that have radicals. Remember, the sides of a triangle often are going, right triangle, are often going to be created using Pythagorean theorem, which means they're going to have a square root. So what happens when, I don't know, I get something like the sine of theta is square root of 3 over 2, and then I say, go find the cosecant. Well, now it's 2 over square root of 3, but no radicals downstairs. That's cosecant. You have to rationalize it. Okay? While we're at it, do we need to go through Pythagorean theorem?
Yes. What?
Okay. But more specifically, so you don't have to reinvent the wheel every time. If a squared plus b squared equals c squared, the way that I would normally write that is if I'm trying to find the hypotenuse is the square root of leg squared plus leg squared. If I'm trying to find a leg, I would have to subtract from the hypotenuse, getting hypotenuse squared minus leg squared. Okay. It's just shorthand. You are not going to see me write out Pythagorean theorem and then solve for missing side. I am just going to write it as square root of this plus or minus that answer. Yes. Okay. I think I mentioned it in here before. Y'all heard that Pythagoras was just straight up cult leader. Okay. Like, those are the axioms of his cult. All was number. Number is a substance of all things, meaning that since everything in the world could be physically described, geometrically described, number is what defines our existence. Number rules the universe. If I know enough numbers, I become omnipotent. Number is the ruler of all forms and ideas, the cause of gods and demons. If I know enough numbers, if I become omnipotent, I become a god. And geometry is the knowledge of the eternally existent. If I know enough math, I transcend mortality. I become an immortal god. He and his followers actually believe this. If you just knew enough math, you could describe the universe and become immortal. He was a straight up cult leader. Okay? Well, she's also got like a 3,000-year head start. So, it's from the book. There's always like a example problem at the top, like lead into the section. Yeah, it does. Kermit's creeping on you. So, go over values of the trig ratios. Everything on here, notice that all three sides are integers. That's not going to happen very often. These are all called Pythagorean triples. Y'all remember Pythagorean triples? Integer numbers that will satisfy Pythagorean theorem. Okay. The most commonly used ones are 3, 4, 5, are 5, 12, 13, and 8, 15, 17. And then there's one with 20s. 20, 21, and... Oh, is that the third one? Okay. So Pythagorean triples are often going to be used in math problems because we can scale them up and down. If a 3, 4, 5 triangle has a ratio that meets Pythagorean theorem, then I could also do something like 33, 44, 55. Y'all got a calculator? Try it. 33 squared plus 44 squared. Square root of that. And you should get 55. Because the 3, 4, 5 triple scales up or down as we need it. Oh, okay. Here. 33, 44, 55. They were just dashes. Okay. Now that works with anything. Oh, also I recommend, because we were recently doing like models and stuff, just reset your calculator. This is a whole different animal. All right. Second plus 7, enter 2. Boop, boop. Or someone reset it. This works for anything. If I do the square root of, watch this, say it's like 3 times 9 pi squared plus 4, oh, wait, parenthesis, 4 times 9 pi squared. Okay? A squared plus b squared equals thing. So I took a 3, 4, 5 triangle and I buffed it up by 9 pi. If I take that answer divided by 9 pi, take a wild guess what's going to happen. 3, 4, 5 triangle. Okay? So they scale by whatever you want. That's why knowing Pythagorean triples comes in really handy. Okay? 3, 4, 5, 5, 12, 13, and 8, 15, 17 are the most commonly used ones. So, they're starting off with, hey, just tell me the ratios. Okay? Sine. If I'm talking about angle theta, might not be a bad idea as we're getting into this, maybe reviewing stuff we haven't done for a year or so, that we label things. 15, opposite, adjacent, or hypotenuse. Adjacent, it is next to. Opposite is across from it. Hypotenuse is across from 90. So, sine is top right corner, the 6 ratios. Get used to those. I have kids who will leave this class, they'll go take Trig with Mr. Spear, and in the middle of a test, I've had them tell me that they just automatically look up and to the left because they're so used to this. Okay, the 6 trig ratios are right there. Sine, opposite over hypotenuse, all I write is 8/17. Always make sure that you reduce them if possible. If there's a radical in there, make sure it's rationalized. So, list them all. The cosine is, the tangent is, the cosecant is, the secant is, and the cotangent is. I said you have to know basic geometry to come in here. Be happy we even have a review section. Okay. Cosine is who over where? Adjacent over hypotenuse, 15/17. Because these are Pythagorean triples and they are reduced down to their primary form, none of these will have to be reduced. Tangent, opposite over adjacent, 8/15. And then cosecant. It is going to be hypotenuse over opposite instead, so 17/8. Always. It's just, that is not simplifying. We go fraction town in this house. Secant. Flip it, hypotenuse over adjacent. And cotangent, flip it, adjacent over opposite. 15/8. Okay? So I write my ratios like this. Cool? And the fun part of that is when you finish every problem, you can say, ha, get ratioed. So, go! Well, both of them, but. Now, if you don't like a triangle that is not nicely laid down on its base for you, turn your paper. Just turn your paper. Okay, start by labeling across from theta.
It's the alligator. Oh.
Okay. Oh, okay. Will do. Yep. Change attendance.
No, Levi.
Okay, these should just be about matching. This thing goes here, that thing goes there. If I go from this angle, I would label opposite, adjacent, and hypotenuse. And then off to the races we go. Sine, opposite over hypotenuse, 5/13. That means my cosecant will be 13/5. Cosine is adjacent over hypotenuse, 12/13, which means my reciprocal, 13/12, is secant. And tangent, opposite over adjacent, is 5/12, meaning cotangent is 12/5. Cool. Especially as we're starting these, it'd be a really good idea to get into the habit of labeling like this. Now, yes, it's on its hypotenuse, which is weird. Label things. From this angle, what is 21? Opposite. 29. Hypotenuse, which leaves adjacent. So 1b, again, opposite over hypotenuse, 21 over 29. Adjacent over hypotenuse, 20 over 29. Tangent is opposite over adjacent, 21 over 20. Cosecant, well, you know what? Just all three of these, flop them. 29 over 21, 29 over 20, and 20 over 21. I would like you to just look at sine, cosine, and tangent. You got any ideas, any observations about what the ratio's probably going to be like every time? Okay. Yes. Going to be a fraction. How about their value? The size of their value. Okay. Not necessarily. Because if I switch theta over to the other angle, now sine would be 12 over 13.
So you can just move theta.
Well, it depends which angle you're talking about. They just happen to be talking about that angle this time. Notice that sine and cosine are proper fractions, less than 1. Tangent is allowed to be either proper or improper. The reason for that is I want you to think about a triangle where, what if I said the sine of theta was 15 over 7. Sine is who over what? Opposite and hypotenuse. So this would be 15 and this would be 7. Why not? Exactly. Hypotenuse has to be the biggest one, and that triangle proportionality theorem says biggest angle, biggest side. It's not possible to have a right triangle where the hypotenuse is smaller than one of the legs. Okay? That's going to lead into our fourth commandment of domain. All right. So now they're going to say, instead of I give you the full triangle, tell me all the ratios. Now it's going to be, I'm going to give you part of it. I'm going to tell you one thing. You find the rest. So the cosine of theta is this. Just draw an arbitrary triangle. It doesn't have to be to scale. Just draw a right triangle with theta on it. So, yeah. I'll throw theta in the corner. Okay? Now, they told me what cosine was. If cosine is 2/5 and cosine is adjacent over hypotenuse, they just told me two of the sides. I know that the adjacent is 2, the hypotenuse is 5. And then they say, go find everything else. Yeah. That's why I said an arbitrary triangle. I mean, if you want. Want me to do that instead? Yeah, I can. I just did. I win. Okay, that's why I said just draw an arbitrary triangle like this so you can wrap your head around it. So we have sine, cosine, tangent, cosecant, secant, and cotangent. So I already know, because they told me, that cosine is 2/5. Without doing any other math, what else could I find? Secant is going to be the reciprocal of that. 5/2. But how do I find the others? Good old Pythagorean's going to get you that missing side, which is the square root of, am I finding a leg or a hypotenuse? So hypotenuse squared minus leg squared. I'm going to say 5 squared minus 2 squared, which is 25 minus 4, or the square root of 21. Don't you dare go to decimal town, or everything that you write on here will be wrong. Okay? Why do you say plus or minus? You would have to solve for this value, so you put the square root there. Tell me, what does a triangle with a leg of negative square root of 21 look like?
You can't have it. You got it.
Okay, so yes, you do put the plus or minus there, but then the negative will always be discredited because it's not possible. So when I go to the other ones, I got to make sure that I rationalize. Sine is opposite over hypotenuse, square root of 21 over 5. That's no big deal. But what about when I go to its reciprocal? Okay, you're going to get real good, if you're not already, at rationalizing on the fly. If I say 5 over the square root of 21, I have to multiply by the square root of 21, getting 5 root of 21 over regular 21. What we do have to be careful about is if that might reduce. What happens if it was 5 over the square root of 15? I can't divide by 5 right now, but after I rationalize, now it's 5 root of 15 over 15. Now you can you can simplify them. Because 15 divided by... If I had 5 over root of 15, multiply by root of... Yes, if I did. So just be careful that you might have to not only rationalize, but rationalize and simplify. You see, when I get all grumbly and say you're any previous teachers that did not force you to work in simplified radicals did you a disservice. This is why. You should have been doing this in geometry. Tangent. Opposite over hypotenuse, or opposite over adjacent. Square root of 21 over 2. So when I do adjacent over opposite, 2 over root of 21 rationalized is 2 root of 21 over 21. Said you're either gonna have to do scratch work off to the side, or you're gonna get real good at rationalizing on the fly. Okay? So they start with this information. It looks like a big whistle. Then you have to find the missing side and then go tell me the rest of the ratios. Okay? Sometimes you luck out and it's a Pythagorean triple. Most of the time you're going to have a radical. Go! No, it's hard to jump back into math mode after a 4-day weekend, but okay, check with your neighbors. Before you go writing out all the ratios, make sure you have the right sides. It was a solid song in 1994. Okay, this is the information we're given. I draw arbitrary triangle. To find the other side, this is another thing is if you know your special right triangle ratios, 30, 60, 90 and 45, 45, 90 are 1 square root of 3, 2 and 1, 1 square root of 2 respectively. If you know those, seeing 1 and 2 as side lengths There's a lot of kids who will just default to writing square root of 3 up here, and then the whole thing is wrong because they're so used to 1 to square root of 3 being ratios. No, it ain't. That's 1 squared plus 2 squared is square root of 5. And then opposite over hypotenuse is 1 over square root of 5. Rationalize it. Adjacent over hypotenuse is 2 over root of 5. Rationalize it. Which makes cosecant nice and easy. Oh, if I have the square root of 5 over 5 and then I flip that, wouldn't it have been easier to just say hypotenuse over opposite? Okay, so you have different options. Sometimes it's easier to flip the ratio. Sometimes it's easier to just recreate it. Okay, so just plain old square root of 5, plain old square root of 5 over 2, and dos. Okay, so we give you one piece of information. Well, technically two, because you know it's a right triangle. And you should be able to find everything else. Are we doing okay with the rationalizing? Okay. Waking our brain back up after a 4-day fog. All right. I am also going to try to go through this a little bit faster just because this should all be review. But if there's ever something that's just completely throwing you for a loop, wait, where did that come from? Stop me. Yes, ma'am. Literally, it's just a name for the ratio. The ratio of this to this.
And why would you find those?
Because if I know the ratio of the sides, I can scale the sides as large and small as I want. Yes. Like, oh yes. You ever seen, have you ever seen by a building site, by highway construction, anything like that? Guy with the little orange vest that's got the tripod and a little laser, and they're looking at stuff? They're doing basic trig. Okay? Any of you who have talked to military recruiters, anyone who's done competitive shooting, you have to know trig forwards and backwards, and you actually have a calculation table with a calculator with you at all times, because the spotter's doing calculations to know how many mil dots you have to be left, right, up, down, and you actually take the curvature of the earth into effect at certain distances. Okay? Oh, both do. But, okay, it doesn't work like, no, it doesn't work like Valorant and Halo and stuff, dude. You don't just, no. There's actual math involved if you want to get a decent shot on something. So, trig is probably one of the most applicable of the specific math branches, because everything is based on triangles because they're so simple. If I have distance to an object and height, I'm good to go. Okay? Speaking of those special right triangles, do you know how they're created? How does a 45, 45, 90 triangle get its ratios in the first place? Okay. If I start with a square, what do you know about squares? Okay. I don't know what the side is, I just know they're all the same. I know those are 90-degree angles, and if I cut it in half, this will be an angle bisector, which means this is 45, 45, 90. Well, if I have a 45, 45, 90 with x and x, how do you find?
It's a bridge game with triangles.
You in physics? Physics? I don't know if Gabe does it or not. A lot of schools in their physics classes will have a bridge construction project where all you get is toothpicks and Elmer's glue. Go. Okay. I got mine up to, we had to span a 3-foot distance, and we ran out of the 45 plates from our weight room on mine. I think we were over like 500 pounds on it with just toothpicks and glue. Because math. Look at a cell phone tower. Look at a radio tower. You notice how they're all a triangular grid, a lattice work of triangles. It's the most stable object that you can possibly have. Look at the boom on a crane. They're made out of triangles for that reason. Okay. Do good old Pythagorean theorem. Figure it out. That side is x, that side is x. Find the hypotenuse. Go. The square root of x squared plus x squared. Two x squared. Simplify. No.
No, it's x root 2. Because you can't take the 2 out.
The 2 can't come out of radical town. That's not a perfect square. So if this is x root of 2, x and x, the x's are just whatever the scale factor of your ratio is. This is 1 square root of 2. And then I can scale that up or down however big or small I need to. You better know special right triangles, the ratios, and how to create them is like a middle school standard. Okay? At the very least, you should have done that basic proof in geometry. Okay. What about 30, 60, 90s? Anyone know how those are made? Okay. Do you know what this is called? It is isosceles, but more. Equilateral. Okay. We had to wiggle our way around it, but it's called equilateral. If this is an equilateral triangle, all sides are the same. I'm going to call them 2x instead of x, just because I know what's coming. It's geometry, yeah. 42. If all the sides are the same, what else has to be true? And we know that the triangle sum theorem states that all triangles have an interior angle sum of? So, they're all 60. And if I were to toss in a perpendicular bisector, which also happens to be an angle bisector, each of these is 30. Well, if this is also a perpendicular bisector, it cuts the segment in half. Do you see why I said the entire side is going to be 2x? Okay. Because I'm betting you wouldn't want to do Pythagorean theorem with variables and a fraction. So I now have this triangle that says x, 2x, what? Do Pythagorean theorem, figure it out. the square root of hypotenuse squared minus leg squared. That's 4x squared minus x squared is the square root of 3x squared, which is x root of 3. Square the entire side. 2 squared is 4. Which gets you your ratios of 1, 2, square root of 3. Now, if you're getting a little confuzzled about where the 1 and the square root of 3 are, how do I know which one's which? Well, how do I know which one's which? Four minus 1. Whatever is across from the 90 has to be the biggest side. 1 is 1, 2 is 2, square root of 3 is approximately about 1.73. It's like 1.729. Okay. So if 90 is across from the hypotenuse, the 2 has to be the hypotenuse. How do I know where the 1 and the square root of 3 go? Because square root of 3 is bigger than 1, it has to be across from the bigger angle. Square root of 3 has got to be across from 60. 1 is the smallest of the 3 numbers up there, so it has to be across from the 30. Smallest angle goes with smallest side. Okay? So we got to know these because you should have this table nearly memorized. I said that I am not big on memorization. I think memorization is stupid. This is one of the things that we just got to know. Okay? You have to know your special right triangles at a minimum because you can use them to create all of the special ratios. A 1 square root of 2, if I'm going from this angle, I'll call that theta. From 45 degrees, sine is what over what? Opposite over hypotenuse. Square root of 2 over 2. Go again, cosine. Adjacent over hypotenuse. Also square root of 2 over 2. Because this is an isosceles right triangle. Tangent. Opposite over adjacent. 1 over 1. Just uno. Flippy flippy. No, red. If I do square root of 2 over 2 and flip it to 2 over square root of 2, I can rationalize and simplify, or hypotenuse over opposite is just square root of 2. So my secant will likewise be square root of 2. And the reciprocal of 1 is just 1. Okay. My ratios are, who goes where? 1 is across from 30. Square root of 3 is across from 60. Hypotenuse is 2. So this is what I meant about no, sine isn't always going to be the smallest because it depends what angle we're looking from. If I'm looking from the 30, this would be opposite, adjacent, and hypotenuse. So go tell me the stuff for 30. Sine. Opposite over hypotenuse. 1/2. 1/2. From the 30. That's why I always make a little mark or something to identify what angle I'm going from. Adjacent over hypotenuse for cosine. Square root of 3 over 2. Tangent. Opposite over hypotenuse becomes 1 over square root of 3, which I rationalize. Square root of 3 over 3. Remember, 1 over square root of 3. Cool? Okay. When I go flipping all of those, the reciprocal of 1/2 is 2 over 1. 2 over root of 3 rationalized. 2 root of 3 over 3. Not just 3, close, root of 3. Okay? Because, again, if I do 3 over root of 3 and rationalize it, okay, it's overkill to do that when I could say the cotangent is adjacent over opposite, just square root of 3 over 1. All right, we're switching things up. I am no longer looking from the 30. We are now looking from the 60. So how do I got to change my labels? Hypotenuse is still hypotenuse. This is now opposite, this is now adjacent. So, opposite over hypotenuse is square root of 3 over 2. Adjacent over hypotenuse is 1 over 2. Opposite over adjacent is square root of 3 over 1. And then they're reciprocals. And at this point, we should start to see a pattern. What do you notice? Like flipped, what do you mean? Okay. You ever wonder why it's called sine and cosine? Think of a co-pilot. Think of a co-captain. They go together. The sine of one is the cosine of its complement. You remember the difference between complementary and supplementary? One of them makes 180, the other makes 90. Which is which? They go in alphabetical order, alphabetical numerical order. Complementary is 90, supplementary is 180. C then S, 90 then 180. So since 30 and 60 are complements, since they happen to add up to 90, that means the sine of 30 is the cosine of 60. The cosine of 30 is the sine of 60. Oh, the fun part of it is if you just know this, you know the other 9. Because These switch. This is the cotangent of the other one. The cotangent of one is the tangent of the other. If I know these two, I know their reciprocals. If I know their reciprocals, okay, because everything just flippity flops. Because if they're complements, that means they're on opposite parts of the triangle. If they're on opposite parts of the triangle, that means when I go from one angle to the other, I just swap adjacent and opposite. So they're going to have all the same numbers. It's just in which ratio. This blank, get used to it. We're going to start a good number of classes, or in the middle of a class, just say, put everything away, do it. We got to know this. Do you see how you can create these ratios as long as you can make the triangle? If you know the triangle and know the definition of SOHCAHTOA, you're good to go. You can create it from scratch every time, which is why this is the only chapter where I am going to have a no notes, no calculator quiz. Because if you know those two triangles, you can create that entire circle. Oh yeah, you can. And most kids get 100 on it. Or they'll get a 90 because they don't read the directions and they forget to put their tangent values next to them. Well, everything up there is sine cosine, but we'll get there. Oh, as we're over here, everyone on a calculator. What is the sine of 30? Y'all, look at the table we just made.
1/2.
1/2. Okay, now type sine of 30 in your calculator. You got 1/2, but other kids aren't. Levi,
What's that?
both calculators do sine of 1/2. Why are they different? We said the sine of 30 what? The sine of 30 rupees? The sine of 30 tacos? The sine of 30 degrees. Hit mode. Your calculator will default to radians, which is a measure that we don't even know about yet. But I've been begging our geometry teachers to put radians into geometry for 8 years. Okay. Switch it over to degrees, please. You should also know, and this might be a good time for you to make a note to yourself, that, oh boy, every time you reset the calculator, it defaults back to radians. You know how many kids just reset the calculator instead of like clearing stuff out in the middle of a test? They just keep resetting it.
I don't have to do that.
That's your personal calculator. You do what you want with it.
No, but like it'll always.
Scientifics usually default to degrees. The graphing calculators will default to radians. Okay, so the square root of 2 is about 1.41. Half of that would be about 0.7-ish. Now that you're in degrees, go do the sine of 45. Yo.
There's an option to put imaginary numbers in like degrees of theta or something.
Mm-hmm.
What?
That's trig.
What'd you I never knew that meant.
What are you talking about?
Because when you go to trigonometry, it'll make more sense after we go through degrees and radians, the next two sections. When you go to trig, you will develop something called polar coordinates, where instead of x and y, everything is distance and rotation.
That's why.
Remembering a question on the ACT?
Yep.
Okay. So, if the sine of 30 and the cosine of 45 and that kind of stuff are in the calculator, then I bet a bunch of other stuff is, and it's because it's a ratio. The ratio is tied to the angle. And if the ratio is tied to the angle, that means I can solve problems where I know or want to find the angle. If I am given 3 pieces of information in a right triangle, I am good to go. 42 degrees is right meow. From right meow, I have an x and an 18, which are in what 2 spots? And which of my ratios uses hypotenuse and adjacent? Okay, cosine and technically also secant, but secant isn't one of the values on my calculator or a button on there because secant is just the reciprocal anyway. So since the cosine of 42 is going to be that thing over that thing, then solve. I'm going to write the expression and then the decimal equivalent of it. Remember proportions, you get to cross multiply and solve. Now instead of saying this times this, that times that, divide by the coefficient of x, you should also remember that with proportions you can just Jesus fish. Multiply the 2 that line up, divide by the 1 that doesn't. Snack that smiles back. Okay. Multiply the 2 that line up, divide by the 1 that doesn't. Because the one that doesn't will be the coefficient in front of x. So I will get x is 18 cosine of 42, and then you'll give me the approximation of it. Yes. Because if we don't see the degree symbol, we have to assume that we're in radians. So, 18 cosine of 42, make sure you're in degrees. What do we got? 3 places, please. Okay. And this is actually where my 3 decimal places rule came from. X. You found it. Whee, there it is. Yeah. Okay, it depends on what ratio you're given though. Sometimes you'll need to use sine, sometimes cosine, sometimes tangent. Sometimes you'll have to divide. Maybe it would have ended up as 18 over cosine of thing. Okay, that's why you're going to write the expression because it's perfect, and then the decimal equivalent, which is what the layperson will understand. Okay? So it all depends on what ratio you have. Again, you may want to label them when you get started. Oh no, they tilted my triangles. Tilt your paper.
Oh my god.
So aggressive.
Yes, just tilt your paper until it looks the way you want it to. Oh boy, there's a joke for that, but I can't at school. Nope.
Just whisper in my ear and then I can say it.
Because I would definitely say it.
Yeah, we know. Who is it?
That was scary.
Well, there you go. Yeah.
So when we have a request,
Hmm.
that you change our name to Trace Leches on the board.
Yes, we would like to be
We
Trace
would like to be
Leches,
the
not
milk
studios.
I think that should definitely be another tally.
And change our name.
Yes.
And change our name.
If you give us the tally, you have to change our name. That is a fair deal. The Trace Leches. Yes.
That was the most worth it point we have ever gotten. Absolutely.
Let's go. Trace Leches.
Guys, we're official. The Trace Leches.
We are officially Trace Leches.
All right.
Trace Leches.
First one, if I'm looking from 53, what two sides do I have? Opposite hypotenuse, which is sine, cosine, or tangent. So if the sine of 53 is opposite over hypotenuse, multiply the two that line up, divide by the one that doesn't. X is 15 over sine of 53. And then you go give me the approximation of it. 18,702. Okay. Like this, my three decimal places, my thousandths place rule, it came from teaching geometry. And I was in a district that had a very, very substandard academic rigor, particularly with their middle school algebra. There were kids coming into geometry that had never seen a quadratic before. Ever. Like, they just didn't do that. Their 8th grade algebra teachers told them to bring their colors to class. She was the gal that should have retired 20 years ago and kept getting shuffled around department to department. Yeah. I had kids who could not. What happens when you were doing, say it was like, remember the area of a right, or the surface area of a right pentagonal pyramid? And you would have to do, the area of the base is ANS, or 1/2 ANS, and the only way to do that was with the trig values. Well, they couldn't work with an expression like this. 15 over sine of 53. Like, they just could not put that on their paper without freaking out. So we went to 3 decimal places, and it turns out it was pretty accurate. Okay, contestant 2. From 21, I have an opposite and a adjacent, which is the tangent of 21 is opposite over adjacent. Again, multiply the two that line up, divide by the one that doesn't. X is 9 over tangent of 21, or a boot. Okay. So this is how I want us to write our answers, both as an expression and also as a decimal approximation. Usually when we get to this unit, you'll get the like 1 or 2 kids who jumped the gun and took physics too early, are just bored out of their mind because they had to learn all of this on the fly, the hard way, when they started physics. After you take PreCalc, you are good to go for physics. All right. Blah, blah, blah words are, hey, do the same thing. It's just going to be in context. So, both. Go. They're, well, yeah, they're the same thing. Could you create the picture from the words, though? Because we're going to do that. No.
Okay.
Now, in this case, the words are, hey, look at the picture as shown.
Okay, that's what I was worried about.
You are going to have to do these from words. Okay? Laughs nervously. I'm in danger. Okay, so just given the information that you have, I would start by identify the angle and label your sides. Once you label your sides, then is it sine, cosine, or tangent you're working with? Set it up, cross multiply solve, write expression and decimal approximation. And they should be fairly fast. Oops. No, that is opposite. What am I doing? Another thing that maybe we do or do not remember from dealing with proportions, especially in geometry when you did similar right triangles, you know you can always just swap your means and extremes. These are the extremes, these are the means. I can just swap those. Ta-da. Okay, so now if I didn't have the calculator on hand, I can also ballpark this. Because look at my angle, 63 degrees, awful close to what? So if I know 30, 60, 90 ratios, I will divide this by square root of 3. So square root of 3 is about 1.73-ish. So it's going to go in there about 1.2 times. And then I will double it to get to my hypotenuse. So I'm going to say about 240. Okay. But you can kind of ballpark it, right? Look at the next one. 48 degrees is awful close to 45. Will x be larger or smaller than 75? Because the angle was a little bit bigger, the side should be a little bit bigger. I'd say it's probably going to be 80-ish. But I will set up from here. This is adjacent, opposite is tangent. Tangent of 48 degrees is opposite over adjacent. Cross multiply solve, 75. Tangent of 48, or about how much?
83.2.
Okay. So, those are nice simple problems. Ooh, there we go. 5. Can you do it when you got to draw it? Do you know your cardinal directions? Never eat soggy waffles, right? Northeast, southwest.
You would not just say it like that. It's and we
Number 5, I want you to be able to draw this out. So it goes north. Due north means it is at a 0 degree relevant angle. 0 degree relevant angle. That means it's not off a little bit, it is exactly on those axes.
It's exactly 80 degrees that way, 80 yards.
Mm-hmm. So first things first, can we even draw this?
How the heck do we know?
Recreation 56 degrees.
Mm-hmm.
Or they use both X.
It's leading us into our next question.
What the heck does that mean?
What are you talking about?
Well, like it says.
We'll just find one before the other. Okay, first let's make sure our picture is right. College campus, library is 80 yards due east of dormitory. So I'm going to put a dormitory here. East is to the right to the library. The college is constructing a sidewalk. Oh wait, and the recreation center is due north of the library. So this is going to be my rec center. College is constructing a sidewalk from the dorm to the rec center. The sidewalk will be at a 56-degree angle with the current sidewalk between the dorm and the library. So this got to be 56 degrees. Remove my 80. There we go. To the nearest yard, how long will the new sidewalk be? So I don't even care about this distance. I want to know how big that's going to be. Well, you would just find one and then the other. You could find one and then Pythagorean your way to the other. You could, yeah, you got options. So from there, I have an adjacent and a hypotenuse, which is cosine adjacent over hypotenuse. Swap my extremes or cross multiply solve. X is 80 over cosine of 56. Or about, how long?
143.
More.
Why? All 6-3. It said to the nearest yard.
I don't care. I've said it several times in here. I don't care what the directions are. We're going to go 3 decimal places. Unless we're talking about money, because money is specifically to the hundredths. Okay?
And why do gas prices have
The same way that, like, you know, this recliner is on sale for $699, so they can say for less than $700. There's like psychological studies that were at the core of that in the 60s and 70s. Is they would always say it's under this amount because then people think they're getting a better deal. It's kind of like the buy so many get so many free thing. How about
What? Bro, you're getting two for the original.
Get second half off.
Almost as if they raised the first price up.
Okay.
Well, then that's the same thing.
So,
What they're essentially doing with the price.
okay, but if you write things a certain way, people are more likely to purchase. For example, artificial scarcity, FOMO. Okay. How many times do they say for a limited time? Or, you know, if you call within, you know, this amount of time, you get this. All of those are meant to create a feeling of urgency in people so they're more impulsive and more likely to buy things when they don't really need them. The same as things are going to be, gas is going to be at 324.9 cents per gallon. Well, they want you to say it's under 325.
I bought so much stuff.
The limited time is a different thing.
Yep.
It's the philosophy of things hurt twice as much as things feel good.
The angles of elevation and depression, that's actually a good place to start next time. But we can finish this off real quick. This works in reverse. If all of my angles have their ratios put into the calculator, then if I know the ratio, I can work backwards to find my angle. And it comes from, well, first of all, let's label what we got here. From this angle, what are we dealing with? Opposite and adjacent. Which ratio is that? So if the tangent of theta is 26 over 11, how do I undo tangent? Inverse tangent. Inverse tangent, inverse functions. Inverse tangent can be written two different ways. It can be written as tangent with the -1 on the tangent. Just like for inverse of a function, I put the -1 on f, not on x. Right? I can also write it as arctangent. Okay? Inverse trig functions are called arc functions. And I undo them with the arctangent of a thing. This is no different than saying the square root of something squared. It's no different than cubing a cube root. They undo each other. Logging an exponent, I get just theta. But I have to do it to both sides in order to get my value. So theta is technically the arctangent of 26 over 11, but then you're going to give me the decimal approximation. The arctangent of 26 over 11 Oh no, I got 1.17. Okay, always check. When you do sine, cosine, and tangent, those values are putting in an angle or getting out an angle. I need to make sure, y'all, every year there's like 1 or 2 kids that will do their entire test in the wrong mode. Every year. So now let's try that again. Boop, boop. Now I get 67 and change. Okay? So, pick up there tomorrow. Am I? Wait, I thought you gave me your notebook. Oh, you gave it to me again for chapter 3. No, take it if you need it. I'm not going to get to it today. Take it if you need it. Chapter 2 is, 3 isn't, because that was on Thursday. I did not get the notebooks done on Thursday. Correct.
Last with number 8.